Hello there and welcome back. In this video, we will discuss conversion of a number in one number system to another one. So as we know, in total, we have got four different number systems: decimal, binary, octal, and hexadecimal, which means we get a total of 12 combinations. Because decimal can be converted to binary, octal, and hexadecimal, which is written here. Similarly, binary can be converted to the remaining three, octal can be converted to the remaining three, and lastly, hexadecimal can be converted to the remaining three. So let's start with the decimal to binary conversion. For this, I will take a real number. And the reason I'm taking a real number is because it will help us understand how to convert a real number in decimal number system to its equivalent in binary. And the same process can be applied to whole numbers as well. So let's get started. For decimal, I'm going to take a number which is 891.375. Now, if we have to convert 891.375 to binary, this is what we will have to do. The first thing we will have to do is we will have to split the number into two parts. One before the decimal, which will be the whole number part, and the one after the decimal, which will be the fractional part. The reason I'm splitting in two parts is because the process to handle both are different. Let's get to them one by one. Let's start off with the whole number part. So for the whole number part, what we will have to do is we will have to divide the whole number, which is 891 in our case, by 2, and we will keep on collecting the remainder. So if I divide 891 by 2, I will get 445 and the remainder will be 1. If I continue this, I'll get 222 as a quotient and 1 as a remainder, then 111, 0 as a remainder, then 55, 1 as a remainder, then I'll get 27, 1 as remainder, then 13, 1 as remainder. Continuing, I'll get 6 and 1, then I'll get 3 and 0, then I'll get 1 and 1, and lastly, it will be 1. So when we continued dividing 891 by 2, we reached a point where we got 0 as the quotient, and that is when we will stop. Now to convert 891 into binary, all we will have to do is we will have to collect the remainder starting from the last one all the way up to the very first, which means 891, which was in decimal, can be written in binary this way. We will have double one, 0 triple one, 1011, and that is it. So this is the binary representation of 891. But the number that we had taken was 891.375. So next, we will discuss how to convert 0.375 into its binary equivalent. For this, what we will have to do is we will have to, instead of dividing, multiply by 2. And when I multiply 0.375 by 2, I'm going to get 0.750. Now, out of the number that we get, we will take the whole number part, write it here separately, and take the fractional part to the next step. And we will repeat the process, which means we will need to multiply 0.75 by 2. This will give us 1.5. We will take the whole number part over here and the decimal part to the next step. We will multiply 0.5 by 2. We will get 1.00. 1 will be taken here and 00 will be taken to the next step. And since we have reached 0, we will stop the process. Now that we are done with this, what we will do is we will collect the numbers starting from the first all the way to the last, which means 0.375 in decimal can be written as 0.011 in binary. Now, to get the answer for 891.375, we will combine these two. If we have a decimal number, 891.375, the binary equivalent is going to be 110 1111 011. So 110 1111 011 dot 011. This will be the binary equivalent of 891.375. So that is how we convert decimal to binary. Next, let's convert from binary to decimal. This will help us serve two purposes. First, we will be able to validate whether the binary equivalent that we got for 891.375 is correct or not. And second, of course, we will get to know how to convert binary to decimal. So let's take the same number. I'll write this down over here quickly. So 110, 1111, 011 dot 011. The first thing that we will have to do over here is we will have to specify the position. So we'll start with the whole number part and we'll start from the rightmost digit. We'll put the position as 0. Then we will keep on going to the left and we will put positions as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And for the fractional part, it will be -1, -2 and -3. Now, the next thing that we will have to do is we will have to find the positional value of all of these digits and then we will need to add them up. So let's do that quickly. For 0, finding the positional value can be skipped because its positional value will be 0. So what we will do is we will find positional value of all the 1 that we have in this number. So the first one is at position 9. So this will be 1 into 2 raised 9. The second one is at position 8. So this will be 2 raised 8. Then 2 raised 6. So this is for the whole number part. For the fractional part, it will be 2 raised -2 and 2 raised -3. So if we solve this, what will we get? 2 to the power 9 can be solved as 2 to the power 3 power 3. And 2 to the power 3 is 8. 8 power 3 or 8 cube is 512. 2 to the power 8 can be solved as either 2 to the power 2 whole power 4 or 2 power 4 whole power 2. One and same. So if we go for 2 to the power 4, it is 16 and 16 square is 256. Another way to solve this could have been 2 power 9 divided by 2, which would have given us 512 by 2, which is equal to 256. Then 2 to the power 6 is 64. 2 to the power 5 is 32. This is 16. This is 8. This is 2. And this is 1. Then 2 to the power -2 is 1 by 4. And 2 to the power -3 is 1 by 8. Let's add this first. So we'll get 2, 6, 8, 12, 14, 20, 28, 30, 31. 3 carried over, 3, 4, 9, 15, 18, 19. 1 carried over and 8. For this, we can go for 1 by 4 plus 1 by 8. Now there are two ways. Either you convert both of them into decimal and add it, or you find the LCM and do the addition. I'll go for the decimal part. So it is 0.25 plus 0.125. And if you add them up, you're going to get 0.375. Again, we'll have to combine these two to get the final result, and the final result is 891.375, which is something that we were expecting anyway. So this is how we can convert binary to decimal. With this, we're done with decimal to binary, and we're also done with binary to decimal. Next, let's discuss how can we convert decimal to octal. Now the process of conversion from decimal to octal will be similar to binary. The only difference will be that instead of dividing by 2, we will divide by 8. And for the fractional part, instead of multiplying by 2, we will multiply by 8. So let's solve this quickly. Again, we'll do it in two separate parts for 891 and separately for 0.375. So for 891, if I divide this by 8, I'm going to get 111 because that will be 888. The remainder will be 3. Then if I do this division of 111 by 8, I'll get 13 because 13 into 8 is 104 and the remainder will be 7. If I do it again, it will be 8 into 1 is 8 and the remainder would be 5. And doing it one more time, we'll get remainder as 1. Similar to decimal to binary, we will collect the remainder starting from the last one all the way to the very first. So we will get 1573 base 8, which is the equivalent of 891 in the decimal format. Next, let's solve for 0.375. So if we multiply 0.375 by 8, what are we going to get? Well, 0.375 is 3 by 8. And 3 by 8 multiplied with 8 will be 3.00. We will collect the whole number part and we will take the decimal part to the next step. And since we have reached 0, we will stop and this will be the answer. Now, if I combine this with this, we are going to get 1573.3 base 8, which is the octal equivalent of 891.375. So let's note this down over here. This will be 1573.3 base 8. And with this, we are done with decimal to octal. Next, let's convert octal to decimal. For conversion of octal to decimal, the process will be similar to binary to decimal. So we will first of all write the number. Then what we will have to do is we will have to find the positional value of each of the digit and then add them up. The only difference between binary to decimal and octal to decimal will be instead of raising by power 2, which we did for binary, we will raise by power 8 because this is octal, which is base 8. So let us quickly write the positions. This is 0, 1, 2, 3, and this is -1. So the positional values will be 1 multiplied with 8 cube. For this, it will be 5 multiplied with 8 square. For this one, 7 multiplied with 8 power 1. And for this, 3 multiplied with 8 power 0. 8 cube is 64 into 8, which is 512. 8 square is 64 into 5 is 320. 8 into 7 is 56, and this will be 3. Now, for this one, that is 3 at the position -1, this will be 3 multiplied with 8 power -1, and this is 3 by 8. Now, if we add all of these up, which is 512 plus 320 plus 56 plus 3 plus 3 by 8, what will we get? Let's go for this first. And this will be 3, 6, 9, 2, 11. So 1 and 1 carried over, 5, 1, 6, 7, 8, and 9. Then we'll have 3 and 5, 8. So 891. This plus 3 by 8. And we know 3 by 8 is 0.375. So 891 plus 0.375 will be 891.375. That is what we were expecting anyway. And with this, we have understood how to convert octal to decimal. Next, let's talk about decimal to hexadecimal conversion. We will take the same number, that is 891.375. Before we convert this to hexadecimal, let's recap. For decimal to binary, what did we do? We split the real number that we have into two parts. So we had 891 and 0.375 separately. We solved for 891, we solved for 0.375, and then we combined the result. The process to convert 891.375 to hexadecimal will be similar to converting decimal to binary or decimal to octal. We will split this into two parts and we will solve for both the parts separately. So how do we solve for 891? In binary, that is when we were converting decimal to binary, we divided by 2. Over here, we will divide by 16 because we are dealing with hexadecimal and hexadecimal has got a base of 16. So this will be 16 into 5, 80, 9, 16 into 5, 80, and remainder will be 11. Then 16, 3, 48, remainder is 7. Then 16, 0, and remainder is 3. Now we need to collect the remainders. But before that, the 11 will need to be converted to B because in hexadecimal, we've got digits from 0 to 9, and the first alphabet is A, whose value will be 10, and the second alphabet is B, whose value is 11, and that is why 11 here is B. Now let us solve for 0.375. The process will be similar. We'll go for 0.375 multiplied with 16. Now 0.375 is 3 by 8. 3 by 8 into 16 is going to give us 6.00. We'll collect 6 over here, take the remainder to the next step, and since the remainder is 0, we will stop, which means our answer is 37b dot 6. So 891.375 converted to hexadecimal will be 37b dot 6. And with this, we have completed decimal to hexadecimal. Next, let's talk about converting binary to octal. For that, what are we going to do is we're going to take this binary number So let me note this down. This will be 1 1 0 1 1 1 1 0 1 1 dot 0 1 1. Now, what will we have to do next is we will have to divide this number in two parts. Again, the whole number part and the fractional part. Once we have done that, for the whole number part, we're going to start from the extreme right and we're going to group this in three. So we'll say 0 1 1 is in one group. Then 1 1 1 will be in another group. Then 1 0 1 will be in another group. And then lastly, we'll have just one over here. And since we were supposed to group in three and we've got only one, what we can do is we can put two zeros over here. Putting two zeros over here will leave the value as it was. Hence, that is not at all a problem. And this will become our group 4. Now, what are we supposed to do next? We're supposed to go for the fractional part. In the fractional part, we've got 3 digits only. Let's call this as group 5. Now, once we have done that, the next step would be to take the numbers in each group and convert it to its decimal equivalent. So, when we convert 0 1 1 to decimal, what do? We have already discussed how to convert binary to decimal. Following the same process, the positional value here will be 2 to the power 0, and for this will be 2 to the power 1. If we add them up, we end up with 3. So, what are we going to do next is we're going to put 3 over here. Similarly, for 1 1 1, it will be 7. You can try it out yourself. For 1 0 1, it will be 5. And for this one, it will be 1. For group 5, it is going to be 3. So what do we have ultimately? We have 1573.3 in octal when we took this binary number. And this is what we were expecting anyway. We are done with binary to octal. Next, let's talk about binary to hexadecimal. For that, we're going to take the same binary number. We will say 1101111 dot 011. And the process will be similar that we followed when converting binary to octal. But instead of creating a group of 3, we will create a group of 4. And of course, we will have to divide the number into the whole number part and the fractional part. For the whole number part, start from the extreme right, make a group of 4. So first group will have 1101 starting from right, or you can say 1011, which is how it should be read anyway. Then the next group will have 0111. Then the next group will have 11. We can put double zeros. For the fractional part, we can say 011, and since this has got only 3 digits, we will add a 0 over here, and this will be our group 4. Now, what are we going to do is we're going to convert each group into its decimal equivalent. So 1011 will be 11. This one will be 7. This one will be 3. And this one over here will be 6. Now, since we are talking about hexadecimal numbers, 11 can be converted to B. So if we combine all of this, we get 37B dot 6 in hexadecimal when the binary number was this. And this is what we were expecting. So this is how we can convert a binary number into hexadecimal, and we're done with this as well. Next, let's talk about the conversion of hexadecimal to decimal. For this, we're going to use 37B.6, which is a hexadecimal number, which we have used already for other conversions. Now, the process of converting hexadecimal to decimal will be similar to the process of converting octal to decimal or binary to decimal, which is the first thing that we will do is we will split this into two parts. So a fractional part and a whole number part. Then we will put positions. Then we will find the positional value and then we will add them up. So the positional value of 3 will be 3 multiplied with 16 square. For 7 will be 7 multiplied with 16. For B will be 11 multiplied with 16 power 0 and 11 because we know B in hexadecimal corresponds to 11. And for this one, which is 6 over here, this is going to be 6 multiplied with 16 power minus 1. Now let's find these values. So 16 square is 256 multiplied by 3 is going to be 768. So we'll say 768. 16 into 7 is 112. 16 power 0 is 1 into 11 is 11. And this will be 6 multiplied with 16 power minus 1. And this is going to be 6 by 16, which is going to be 3 by 8. Now, if we add them up, we get 768 plus 112 plus 11 plus 3 by 8, which we know is 0.375. So our result will be 0.375 in the decimal part. For the whole number part, it will be 8 plus 10 plus 1, 11. 1 carry 6, 7, 8, 9, and 8. So 891.375 in decimal. And this is something we expected anyway. So this is how we can convert hexadecimal to decimal. And with this, we're done with one more conversion. Next, let's convert octal to binary. For that, let's use this number, which is 1573.3. And the process of conversion of octal to binary is very simple, very straightforward. All that you'll have to do is treat each of the digit as a decimal number, which means it is in the decimal number system. Find its binary equivalent and then merge them all together. Let me tell you how. We know that 1 in decimal number system can be written as 001 in binary, 5 can be written as 101, 7 can be written as 111, 3 can be written as 011 and 011 here as well. Put a decimal in between and we have our binary number which corresponds to this octal number, which is starting from the extreme right 110 dot 110 111 101. So 111 101 and 100. So 1 over here. This is how we can convert from octal to binary. With this, we are done with one more conversion. Next, let's talk about how can we convert hexadecimal to binary. Let's take 37b.6, and the process of converting hexadecimal to binary will be similar to the process of converting octal to binary. Over here, we will assume that each digit in the hexadecimal number is in decimal format. So 3 will remain 3, 7 will remain 7, B will become 11, and 6 will remain 6. Now, we will convert this to its binary equivalent. And in octal, what we did was whatever number we had was converted to its binary equivalent as well, but it had 3 digits. Over here, when we convert each of this to its binary equivalent, we will have to maintain a group of 4 digits. I'll explain why in a moment. So 3, as we know, is 0011. 7 will be 0111. 11 will be 1011. And 6 will be 0110. Now, if you write this together, we will get 0011, 0111, 1011 dot 011. And if you compare this with what we have over here, you will see that both are same. To the right of decimal, we have 011. Then for the whole number part, starting from the extreme right, we have got 1101. So we have 1101. Then we should have 1110. And we have 1110. And lastly, we have 100. Over here, we have just 1. So this is how we can convert hexadecimal to binary. Now remember that I told you that when we convert a hexadecimal to binary, we consider each of these digits as it is present in decimal number system, and considering that, we convert them to its binary equivalent. And when we convert it to its binary equivalent, we have to maintain a group of 4. Let us understand why, and with this explanation, you will be able to understand why we maintained a group of 3 when it was the case for octal to binary conversion. So as we know, for hexadecimal, we can have digits between 0 and 9 and letters or alphabets from A to F. This makes it a total of 16, 0 being the lowest and F being the highest, which is for 15. If you represent 15 in binary, the binary equivalent will be 1111. If you represent 0, you can either represent it as 0 or 00 or 000 or 4 zeros, doesn't matter. But if you take the highest number that is there in the hexadecimal number system, it needs 4 bits to be represented. And because the highest number in hexadecimal needs 4 bits. When we convert hexadecimal to binary, we maintain a group of 4. Similarly, for octal, the range of digits is from 0 all the way to 7. 7 can be represented in binary as 111, needing 3 bits. And that is why there we maintained a group of 3. The two conversions that we are left with is octal to hexadecimal and hexadecimal to octal. So let us talk about both of them. If we were to convert an octal number to a hexadecimal number, what will we have to do is we'll first of all have to convert octal to binary and then convert that binary to hexadecimal. Now, we know both of these conversions. We have already discussed how to convert octal to binary, and we have also discussed how to convert binary to hexadecimal. Similarly, if we have to convert hexadecimal to octal, we will have to go for hexadecimal to binary and binary to octal. And we know how to convert hexadecimal to binary because we have discussed this already. And we also know how to convert binary to octal because we have discussed that as well. So with this, we complete all of the conversions that we can have considering these 4 number systems. This brings us to the end of this video. I hope I've been able to teach you something new and useful. If you have any suggestions, queries, or feedback, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.